Okay, so we could also say, hey, take this grammar we just made, and we made it so we can have an article in there in front of nouns. What about verbs? Maybe I want to have an S or an ED at the end of a verb. Okay, well, I can conjugate a verb. And so, yeah, you can think about how to do that. I have a little answer in the notes here of one way. I want to go down and now look at, let's make up a new grammar for a Java field declaration. Okay, so let's go here and go some space, new screen space. A grammar for Java field declaration. I know we're not writing code here, but some of the steps of the design recipe are still helpful. Let's do some test cases. So give me some concrete Java field declarations. What sort of things do we need to account for if we're going to be making a grammar for this, the official rules for this? So what are some of the things you can do in a Java field declaration? This will have to be inside a class and not inside a method, but that's not our question about where it occurs. When it does occur, what does it look like? I'll call this sorry. So what are some examples? Int n, semicolon. Okay. It can also be something like double x gets 3.14. Okay. What else can we have? Gosh, we can have private static private static string gets gosh, okay, so a lot of different things. We're going to offshore some of this. In particular, I'll tell you right now, everything on the right-hand side of the assignment, we're going to say that can be any expression, okay? Anything between the equal sign and a semicolon, if you're initializing a field, could be any expression, and we're going to leave it at that. But okay, so let's go ahead and do, these are examples of the data, if you will. We might come back and see if we can actually derive these from our definition. So, oops, this is wrong. Private static string. I need a name here, don't I? An identifier. My stuff. Okay. Gosh, exactly what is a name? Turns out, what is a valid name in Java? Yeah, we're going to offshore that too. You can go and look up what is a valid Java identifier, and there's a whole grammar for it. Okay, in fact, we will come back and look at that later. But just for now, let's take our word for it. There's already some other non-terminal people have defined for identifier that corresponds to a Java identifier. So what do we want? We want to have a field declaration can be let me start with the first couple, and then I'll start with the first one, and then I'll refine it to capture more and more things here. If I'd just seen the first one, it's like, okay, this is going to be a type followed by an identifier followed by a semicolon. And I'll use a little convention. The things that I start with capital letters are going to be my non-terminals. Okay, so type will replace it with some particular type. ID will replace it with some particular ID. Okay. Yeah, so a type followed by an identifier followed by a semicolon, where type, we're not going to go further into that. Identifier, we're not going to go further into that. But semicolon, yeah, that's a terminal. Have to have that semicolon there. We could also have a field decl could also be, here's another root, could be a type followed by an identifier followed by the equal sign followed by any expression, semicolon. Okay, that now, these two rules together take care of this. Can I have these two as, can I have two rules for fieldDecl? Sure. Remember the grammar game. Hey, can you go from this string to that string only using the rules available to you? Well, we have two different rules available to us for fieldDecl at the moment. And then, oh gosh, all this like private and static stuff that can go ahead of the string. In some sense, this rule here is accounting for all this, but gosh, private and static and I'm going to go ahead and say something. We'll have to come back a little bit to really get it right. I'm going to say for both, in front of both of these, we can have modifiers. Okay, so modifiers, that's all the different things you can throw in front. Private and static or public and synchronized and all the different adjectives Java allows. So somewhere, gosh, I will have to say modifier can be public or private or, what is it, protected. Package protected, that's what you get when you don't have any modifier. Oh, you can have nothing at all for a modifier, right? So we'll come. Let me start with just if I had a declaration that only handled a single modifier. Okay, so we're not going to, we'll have to come back to saying multiple modifiers. Public, private, protected, synchronized. Gosh, there's like two or three others maybe that are more and more, or less and less common perhaps, especially in student level assignments. I'll go look those up in some. Actually, if I go look it up, I'm probably just going to be looking up the grammar that somebody else wrote for me. But yeah, okay. So I could say, hey, have a single modifier followed. Now, of course, I also want to say that there's possibly no modifier. Okay, and one way to do that would be to double each of these rules, one with a modifier, one without. So I could go ahead and double those rules and then take out those. I can say I have 4 rules now. This lets me capture any single modifier or 0 modifiers, 0 or 1. But I don't quite, there's a faster way to do this. We can factor out that common stuff. We can go ahead and say, modifier could be public, private, protected, or it can be nothing at all. Instead of replacing, when I'm playing the grammar game and I'm building up some string and I'm getting closer and closer to something like this, rather than saying, hey, I can take modifier and replace it with the word protected, or I can take modifier and replace it with public, I can take modifier and replace it with the empty string. So I could go ahead here, I'm going to go ahead and I'll add it right here maybe. There we are. Well, it's a little bit hard to see the empty string in there, especially when I'm padding it with white space. So there's a special symbol people will use, epsilon. In this class, we'll use epsilon as a way to mean the empty string, because otherwise it's kind of hard to see because we're not using quotes around everything. And that's pretty common for grammars to use epsilon. Some people will use lambda sometimes to represent the empty string. We'll use epsilon. Okay, little Greek E. Okay, so now we're pretty close. We can go ahead and generate, we can't again generate 2 modifiers yet. We'll come back to that. I'm going to go ahead and leave that as a test case. It's a test case I'm currently failing in some sense. Can you go ahead and derive this string from fieldDecl? So that is, let's play let's see if our grammar really seems to be good. I want to play the grammar game. I'm going to start with this string, fieldDecl, and by doing a bunch of derivations, I want to end up with that string up here, the private string of my stuff. Okay, we do it. So go ahead and pause the video, see if we can try to go ahead and, starting with fieldDecl, do the allowed. I have 3 rules here. And I guess the third one is a bunch of individual cases. Can I go ahead and come up with a private string, my stuff, blah, blah, blah. Let me help you out. Let me do an easier one first. Let's go ahead and do the int n. semicolon. Can I go ahead from fieldDecl and get to int n? Yeah, if I want to do that, I would go fieldDecl. A fieldDecl is replaced by a modifier, and then a type, and then an ID, and then a semicolon. Okay. And again, my goal is going to get to int n semicolon. Okay, so what can I do? Again, I'll try this left to right thing. I'll try modifier first. What modifier did we have in int n? We didn't have any, so I'm going to use that rule about the using the empty string. So now I'm just saying this can go to type ID semicolon. And if I want to, I can go ahead and say this is rule. If I numbered my rules 1A, 1B, and 2A, B, C, D, 2D. Oops. Okay. fieldDecl went to modifier. That was rule 1A. Type ID. How can I get from type ID to, I want to replace type with int. And you know, it's sort of, yeah, type was, int is a valid type. And I said we're going to offshore this rule. So this, for this one, I'm going to say, yeah, go ahead and by not shown here rules for type. So somewhere there's rules for what can we replace a type by. The fact that for type can go to int. It's going to be somewhere in the rules. Okay, type can be int. ID, similarly, ID goes to n. Yeah, that's going to be similar to this. Okay, the fact that ID can become n. Again, there'll be some of the rules for what are valid identifiers. Might be a bunch of steps. But yeah, I'll go ahead and, okay, so I can get from fieldDecl to int n semicolon using these rules, assuming we have other rules to handle the details of type and ID. Okay, so now go ahead and, oh, you already did pause? And you did this whole thing before I give you that example? Oh, sorry. Okay, well, how can I get from fieldDecl all the way to this here? I'm going to go ahead, this is the slightly different variant, modifier type ID equal sign expression semicolon. Okay. Modifier, I'm going to turn into private. What was the rule that gave me that? That was rule 2A or something? 2B? Okay. The fact that type can, I can replace the string type with the string string. Yeah, and that's by not showing rules for type. Okay, now we're getting closer. Same, the not showing rules for identifier can give us private string. This now, I've offshored so much it's no longer interesting maybe, but my stuff gets expert. Okay. Oops. Oops. The identifier that I wanted to match. I want to end up matching the identifier my stuff with 2F, so I better have that. And now whoomph. We come down to here. With that last step being by not shown here rules for expert. It turns out that is a valid expert in Java. Whatever the, man, I don't envy the person who has to come up with the rules for expert, because that's going to be a lot of different stuff. But we're going to write our own language in this class, right? Our own interpreter. We're going to have to come up with a grammar for it. We're going to have to write the rules for the grammar. We're going to have expressions. Oh, crap. Oh, well. we'll cross that bridge when we come to it. Okay, so this is fieldDecl and how I can go ahead and how fieldDecl, the string fieldDecl, can generate this string that is entirely terminals. Okay. Sounds good. And again here, it's playing the grammar game. Can you get from this string to this string just following the substitution rules? You can take any non-terminal and replace it with whatever the right-hand side of the rule is.